RBAC inside of Kubernetes. So kind of a journey of what it is, why it matters. I am the CTO and co-founder of a company called KSOC. You can guess what the K stands for. I have been using Kubernetes in production since 0.8, which is my stamp of approval or disapproval. So spend some time in this ecosystem, learn some things, and hopefully we can share those today. So let's dive right in. So brief agenda. We're going to kind of cover the basics. What is Kubernetes in a single slide? Does anybody use Kubernetes here? Look at that. Okay. I'm sorry for your loss. Anybody actually dealing with RBAC day to day, trying to build a system in their place of work around authenticating users? Do we have to do that? Yeah, a little bit? You're just cluster admin, good to go? Okay. So we're going to talk about what Kubernetes is and why identity matters, right? That's kind of the buzzword. We'll probably say the word zero trust one time so you can check it off your buzzword bingo card. And also expand on the RBAC terminology, right? There's a lot going on under the hood when you run kubectl, get pods, all namespaces, right? We're going to go through that flow, how it works. We're going to tie it back into authentication, because that matters too, right? Proving you are who you said you are, and then what you are allowed to do in the cluster. Some of the built-ins, gotchas, and then how do we make RBAC better, right? That's the end of the journey, is to kind of level up your RBAC program in your organization. And if you like slides and you're on your laptop and you like also clicking random shortened links, you can go view the slides as we go at tinyurl.com/ndc-K8s, if you wish, or not. So we kind of know, everybody raised their hand, what Kubernetes is, right? It's a container orchestration system. It does a lot more these days. We are approaching 1.26 or so as the latest release. It's been around since 2013 in open source land, and it's used everywhere. We have managed Kubernetes, we have on-prem Kubernetes. We talked about yesterday, I worked with a customer that runs Kubernetes nodes in fake rocks, and they use it to monitor the weather and eavesdrop on people out in the desert. So you can use Kubernetes for just about anything. Today's focus, obviously, is RBAC, and that stands for what? Role-based access control, right? So this is a very special thing in Kubernetes. RBAC as a concept has existed for forever, but today we're going to talk about Kubernetes RBAC. So identity is the new perimeter, right? So who you are matters. When I started using Kubernetes in 2015, we only created one user, cluster-admin. And we would share that user in not great ways with the rest of the ops team. Why is that bad, right? Because I don't know who's doing what at any given moment in the cluster. And Kubernetes is a very complicated system. It's the new cloud, right? You can list secrets, store secrets, you can create workloads. You can actually kind of pivot, if you wish, outside of the cluster context and get access to AWS, for example. So it's not good to share identities in general in the year 2023. It's really bad if you do it inside of Kubernetes, and we'll talk about why. So we come into the cluster, we have an identity token, something that we've proven we're authenticated and allowed to be there. Then what happens, right? That's the flow we're going to discuss today. So Steve here is actually going to give a talk later on a new project we've been working on for the past 6 months through the OWASP organization. And I just want to outline, it is number 3, overly permissive RBAC configurations, right, in this new OWASP top 10 rendition just for Kubernetes. This is a big deal. It has serious ramifications, and we see this happening in the issues happening out in the world during engagements all the time, and they always lead back to RBAC being overly permissive. So here's the flow of a request, right? Have we used kubectl before? Followed some tutorial, kubectl, get pods. all namespaces, create a pod, things like that, right? kubectl is the CLI utility we use to interact with Kubernetes. But really, you can talk to Kubernetes through a variety of different ways, right? We can talk to Kubernetes via a service account. These are special tokens in the form of secrets that you present to the API server, and usually from the inside of the cluster, to ask to do things, right? They're headless users, and we've used service account tokens for years. Kubernetes is no different. We can use them inside or outside. And then we have different clients and all sorts of, you can use curl if you wish to interact with Kubernetes. So it doesn't really matter how you get there. What matters is this flow in the middle. So you have our API server. This is a very special component inside of Kubernetes, right? First step, who are you? Are you supposed to be here? Are you a valid user? You can use AWS IAM. You can use hard-coded tokens. You can use Okta. There's a variety of ways to actually validate that this is an authenticated, legitimate user. The next step, which is more the RBAC focus, is what can you do, right? So it's one thing to say, I'm here, I'm allowed to make a request to the API. It's another thing to actually put the pieces together and say, Jimmy is allowed to get a specific pod in a specific namespace, or list secrets in the kubesystem namespace. These are objects and these are verbs, right? And then admission control, which we won't really discuss too much today, is are there policies or some sort of governance around this request? And then things happen, magic Kubernetes, fairy dust sprinkles, and then your workload is scheduled on a node. So what does RBAC do? Per the OWASP top 10, enables fine-grained access for users, groups, and service accounts within Kubernetes. That can be extremely difficult to scope appropriately, right? Which is why we're spending time talking about it today. So what does that really mean? So you have kind of three key players or batches of kind of objects that we're dealing with when we build an RBAC policy. First one, users, pretty simple. Me, Jimmy at ksoc.com, or Jenkins, right? Jenkins would be an example of a service account, maybe that's running inside of the cluster that needs to talk to the API. And then API resources, right? There's a great command, kubectl API-resources-OY that prints out everything to the screen you could possibly want to see when it comes to the resources available in your cluster. These are pods, secrets, services, etc. And then operations. HTTP verbs, essentially, right? Get, list, delete, patch, etc., etc. When you create an RBAC policy, you're just having some combination of these together to give a user or service account the authorization to perform that particular task. So the terminology, roles, cluster roles, role bindings, cluster role bindings. What you will notice in Kubernetes is there is no kubectl get users. Doesn't exist. Kubernetes doesn't care, right? It's a bring your own authentication mechanism. So what you are responsible for is making those bindings work in a way that's usable for an end user, but also least permissive, right? And that's really, really tricky, right? So I'll kind of give some examples here. Sorry for the YAML. That's just the world we live in today. So first thing is a role, right? As defined by our kind at the top. This is a Kubernetes object, and we scope a role to a namespace typically. But the important thing here is down below, these resources, right? You're explicitly defining what is allowed. You notice there's no deny here. It's not, that's not how RBAC works in Kubernetes. It's always an allow list, and everything else is denied. So you have verbs and resources, and no binding though, right? We have no concept of a user yet here, and we'll get into that in a second. And this particular role is used in the dev group 1 namespace. Cluster role, very similar, except you can guess that it's cluster-wide, right? So these two lines below also support stars. What do stars do, typically? What is a star if I threw it down in the resources block? Well, everything, right? That's the YOLO button, right? And you can put a star there, and you will just have access to all resources, right? And the single quickest audit you can do in your cluster, and we'll talk about how to do that in a second, is just the presence of a star, right? And that could possibly mean that somebody was a little lazy and didn't want to actually give the access necessary. So how do we actually take a user or a subject in Kubernetes language and bind it to that role or cluster role? Well, role bindings and cluster role bindings, right? So you could see some unique blocks here. Yeah, and I apologize if you didn't want to watch me talk about YAML at 10:30 in the morning, but here we are. You can see some unique blocks here under subject, right? This user Jane is allowed to read pods in the default namespace, right? So we take our subject and our role reference down below, and we tie those together. This is the binding, right? It's very literal. And we say, this subject is now bound to this role that we just created previously, and that gives Jane access to do the thing that Jane needs to do, right? Which is apparently reading pods in the default namespace, which is a problem in another way, but that's okay. And then cluster role binding, right? So this is just a cluster-wide scope. So your job now, as an operator or security team, is number one, audit your cluster, figure out what is running, what RBAC exists. Then number two, make it better, right? And that's what we're going to kind of dive into for the rest of the talk. So Kubernetes out of the box, and we see this all the time, comes with some what they call and define as user-facing cluster roles. Some of these are to be used as roles, but that's a different story. And this is something Kubernetes gives us and has been giving us since the beginning, for us to use instead of the pain and suffering that is custom RBAC, right? So the top one, probably the most commonly used user-facing cluster role, it's called cluster admin, right? This is what you get if you've ever spun up a GKE cluster or something in EKS. Your first experience with Kubernetes is probably using cluster admin or something like it. And as you can imagine, star, 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 star. There's, as Steve put it, 5-star review, right? And that's any resource at any time. And that presents problems for obvious reasons, but that doesn't mean that the rest of these built-ins are exactly perfect. Oftentimes, we'll see folks giving developers admin access. Like they'll be placing every developer in an organization, potentially hundreds of developers who can access a single cluster as admin, right? But that's read-write access across namespaces, and sometimes it gives you the ability to actually alter cluster roles, which is a whole different problem. And then you can go down all the way to view, right? So we'll see why view is also dangerous in a second in the gotchas section, but this is what Kubernetes is going to provide out of the box. So here's a cluster role binding. Let's figure out what's wrong with this, right? Again, back to YAML, and this is an interesting one because it's combining some other configuration that is not so desirable. So number one, we have a single subject, right? A subject can be a service account, a group, or just a user, right, as we saw with Jane. In this case, we're talking about a service account called default, but it's also in the default namespace. That's interesting, right? So there's this token called a service account that's just sitting in this namespace, ready to be used. Pods can consume it, present it to the API, and authenticate to the server. The dangerous part happens below, right? You are basically taking a static token that lots of different workloads can use, binding it to this lovely cluster role called cluster-admin. So stars across the board, you can access the cluster, do whatever you want. The problem here is that the AppSec side of me always loves to try to find things like remote code execution or traversing through files or directories, server-side request forgery. So if you discover this token that's now sitting there in your file system on your pod, you can replay that token to the Kubernetes API, and you are admin. You can do whatever you want, right? So it's a pretty dangerous thing, and I'm not sure that the average security engineer that's kind of just like scrolling through thousands of lines of YAML, this wouldn't necessarily pop out, to me at least, right? So we have some tools out there that attempt to visualize RBAC. Some work, some don't. That's okay, right? This is a hard problem because there is no kubectl audit RBAC command. Like, it doesn't exist. So you end up with somebody else's kind of representation of what RBAC should look like. This tool, Rackus, pretty good, right? It kind of gives you green checks or red X's on who has access to what. Still doesn't say if it's good or bad. It's up to you to make that decision. And then there's quite a few different visualization tools. This one is called RBAC with a K, very clever. And this is great if you're looking at a tiny little sliver of the cluster, but it becomes unusable, untenable at a large scale. But it is a start, right? We can actually start to view what's going on inside of the RBAC landscape because it is such a problem. We've built a cluster role and role aggregation mechanism at KSOC as part of our kind of offering, and it's our take on a visualization. So the big problem is we don't have the connective tissue in the single command. So if you see down below, we can actually say this service account can do these things in this namespace or cluster-wide in a single view, which seems crazy that is novel, but it actually is inside of Kubernetes RBAC. So within, this is a really interesting submission actually to the OWASP top 10 that we had a few months ago. The verbs themselves, right, that we talked about, get, list, post, delete, these verbs that are supported by the API server don't always do exactly what you think they should, right? And this actually came to a surprise to me when somebody submitted this, and I'll show you why in a second. But list and watch are two verbs that are available. They seem benign, right? If you've ever run kubectl watch on pods in a namespace, right? Typically, you're going to see the pod name and the status, right? How many containers within that pod are up. And that's it. Like, that's what you would expect out of a watch style command. But what we've learned is that's not actually the case. As you can see, kind of alluded to into this redacted block down below, and I'll show you that in a second. So the kind of example here is using kubectl versus a curl command, right? Like I said in the beginning, you can interact with Kubernetes pretty much any way you want. And when you use kubectl, we have this example role with myself, service account Jimmy, that is actually allowed to what? List secrets, right? That's the only permission that Jimmy, this service account, has access to do. A list in my mind, maybe my mind is not correct, should not expose the actual content of the payload when it's returned back. It should be a list of the name of each individual secret in this case. So you can store Kubernetes secrets. People do it all the time. Your cluster probably has secrets in it that you didn't realize. So that list command, when you run kubectl list secret in XYZ namespace, really when you run kubectl only shows the name of the secret. Fine, right? That's not a problem. Any old developer can have access to that. So what this gentleman who contributed to the OWASP project with us has discovered is that all you have to do is run a curl command with that same permission, and it actually prints to the screen I only have access to list, but it prints the secret key value, plain text, base64 encoded. That is not a 0-day. That's not actually a vulnerability. It's just how Kubernetes works. And these are the gotchas that really are causing problems in kind of the greater RBAC ecosystem. We get how that works because it's pretty dangerous, right? A list dumps secrets to the screen, right? Which is really not the intention. That should be a describe action. So you can write policies in a variety of different languages to detect things like this. It's not perfect. This is kind of static analysis of YAML. But we have built rules along the lines of the title here, right? It's pretty self-explanatory. Minimize wildcard use in roles and cluster roles, right? That's a CIS benchmark standard. Like you can start there and it's a great start, right? So when you run that across a noisy large cluster, you're actually going to find that a lot of the tools that you don't own, Flux in this case, or Argo CD, or Istio, or whatever it is, pulled in RBAC, and it needs access to crazy things. Maybe it needs it, maybe it doesn't. And you're going to find your third parties are violating RBAC best practice, right? So in this case, you have a cluster role that Flux has created, and Flux is just a continuous delivery platform that runs in the cluster, similar to Argo CD. What is this, right? That's everything. We don't call it cluster admin here, but it's 5 stars across the board. It's the best review you can get. So one thing you can do, and what we use is we use Open Policy Agent. There's actually a talk happening right now, so I'm glad you're here on OPA and Rego, to kind of comb through the entire landscape of the cluster, right? And you're going to surface things like this that you had no idea existed. And some of them are almost not fixable. We don't really know what Flux needs, right? But probably not this. So how do we make this a little better? We have this concept of audit logs inside of Kubernetes. Has anybody read these logs before, other than me? They're actually really exciting, right? So the API server generates this rich set of logs to tell you the exact story of every single request that's coming across the wire from the API server itself. And it, which verb, who did it, when did it happen, what IP address, and where do most of these logs go in large organizations? Just straight to S3, never to be seen again, or they don't collect them at all. So our recommendation is always use them, right? You don't have to read every log, but there's some really deep insight into who's doing what from an RBAC perspective in that cluster. And I know this is a little hard to see, but this is what a log entry inside of Kubernetes would look like. And again, if you're running EKS or AKS or some sort of managed Kubernetes, like you just have to click a button and like you get this pretty much for free, right? You just pay for storage. So these logs have some interesting data points, right? We have an IP address. We know where you came from. Yes, it can be spoofed. We know that, but at least it's a start. We have the response status. We have the user agent, right? We can see that Jimmy is using an old version of kubectl, or he's hitting the Kubernetes API with curl, and that's weird, or wget or something odd. And then down below is how we use these logs to make our RBAC story better. I know it's hard to see, but there's 2 lines here. First one is the decision. Important, allow or deny. Was this request allowed through the RBAC ecosystem or not? And then the reason. And I'm very thankful that Kubernetes decided to bundle this, right? They didn't probably have to do that, but because of that reason, we can tie it back to existing policies that you have in place, roles and cluster roles and things of that nature. So you can use your audit log in a variety of ways to do better RBAC across the board. There's a tool that's gained some traction over the years. It's not highly maintained, but it works, called Audit to RBAC, down below. And the whole premise here, if you use Audit to RBAC or not, there's a couple options, is take this log file, this giant set of logs, and then give me RBAC that fits in the mold of what people are doing, or service accounts, right? So you can actually get to this point of least privilege. And there's new tools coming out in that sort of space as well. So let's talk about how authentication ties into this. Do a time check. The whole concept of authentication is usually handled solely outside of Kubernetes, right? And it still plays a role inside of the RBAC kind of decisioning engine, but authentication itself is pretty complicated. So bear with me. Lots of boxes, lots of lines. I'm going to walk through. Who here has used EKS before? Yeah, a couple people. That's AWS's managed Kubernetes service, right? So if you run EKS, a bunch of magic happens, and all of a sudden after pain, there's magic, but there is magic that happens where you can access the cluster using your IAM credentials, right? This is how you authenticate inside of AWS. And it was always kind of like, no one talks about how we got there, right? There's some stuff that needs to happen, and it's worth discussing because it ties directly into RBAC, right? So again, we have our different types of users, origins, if you will, of a request to the API server. And when you're using something like EKS that actually ties into IAM, there's some interesting components that have to make some elevated calls, if you will. GKE is the same, AKS is the same in some degree. They all work like this, right? So I come in, kubectl, list secrets. I'm Jimmy, I authenticated to AWS, and I'm going to pass that IAM token along with my desired request, like list secrets. The API server then bounces that to this special AWS IAM authenticator server, right? And it talks to AWS IAM, which means it has access to AWS, which is a different part of your threat model. And then we get an identity back. But Kubernetes doesn't speak AWS. It doesn't care. It doesn't understand what an AWS identity is. We have to translate that IAM identity to a subject, right? Like we saw in our cluster role bindings, we have subjects that can be groups, and that's typically what you use here, or just individual users. And then we have this special AWS config map that sits in our cluster that maintains this state. And only then can we take that subject, combine it back with our action that we wanted, and then RBAC kicks in, right? And it's going to say, yeah, you can do that. So every request you make to Kubernetes is going to go through this flow, which is, not something you would see. And this is how it all ties together, right? So there's other pieces of RBAC that make it, I know this is a wall of text, but we'll go through it in a second, that make it complicated, right? When I think of misconfigured RBAC, it's not typically some rogue insider. That's part of the threat, right? I have some sort of engineer that just went crazy one day and he wants to just kind of smash the keyboard and steal some things. What we see happening is a vulnerable workload, right? There's a web app flaw, remote code execution, as I mentioned before. Somebody steals a service account token. Somebody checks in their kubeconfig into GitHub, and it's public for some reason. Like, those are the kind of things we have to worry about. And if you're running Kubernetes inside of a cloud provider, there's a chance that it's publicly accessible, right? We found last year through a Shodan search that there were like 950,000 publicly accessible Kubernetes APIs. That's just like one day of scanning, right? That's not even the full picture. So you have to harden the cluster from a more holistic perspective, and RBAC is one piece, right? So privilege mode, we have all sorts of configuration around volume mounts. Who is that container running as? And do you have any policies in place, whether it's the deprecated pod security policies, open policy agent, or something of that nature? Is there anything stopping bad things from entering the cluster? How do you store secrets, right? Because RBAC, if you can list secrets or you can steal a token that can get to the API and it has secrets capability, you can dump the secrets and do what you will with them. And then least privilege, right? We talked about a few ways to handle least privilege, but step one, look for wildcards. Step two, put some admission control in place, check your logs, use groups appropriately, etc. And then networking. Networking kind of plays into RBAC as well. Pod A, maybe it shouldn't be allowed to talk to pod B, so we can use things like network policies to actually enforce that. And where are you sending your audit logs? This is an area that's vastly underserved. There's really not a good anomaly detection approach out there in open source or commercially that takes these audit logs and surfaces real insights about who's talking to the cluster from inside and out. Imagine a world where you can have an alert that says, we just noticed a service account token called Jenkins is coming from a public IP address and accessing your Kubernetes API. That from an IP you don't even recognize. That could be a huge problem. That's full cluster compromise, right? And then inventory, right? So make sure to maintain kind of an overall inventory of what's running in your cluster. scan it for misconfigurations, right? That's going to be talked about ad nauseum later, and then have a plan of action to kind of harden these things, right? So, and there's also threat modeling. I don't know if anybody here does proper threat modeling in their day-to-day, but there is a whole world of Kubernetes-specific threat modeling exercises that you can perform where RBAC, user access, service account access, actually has something, has a big place in that threat modeling exercise. So that's about it, and we're going to, I have time for questions, war stories, what have you. If you would like to talk, Jimmy@kstock.com, or just Jim Mesta on Twitter for those of us who are just still hanging out on Twitter. I'm still there for some reason. Yeah, so thanks for coming, and hopefully you found that useful. We'll see you around the conference. Any questions?
I have one question
Yeah.
about the secrets where list was the vulnerability,
Mm-hmm.
side consequence. Does that only apply to secrets or all kind of objects?
It's a great question. Does this example only apply to secrets, right? So, again, it applies to any object, right? Secrets are impactful because they have this items block, right? So I would say this applies to everything. Secrets are the top priority. And then for me, number 2 would be config maps. The same behavior works with config maps. And if you're not familiar, that's how we store general configuration inside of Kubernetes. But sometimes it can be sensitive. So it would operate all the same for config maps. Any questions? Yeah?
Question about namespace, 5-star
Yeah.
access. Is that a huge problem?
That's a great question. So five-star review, scope down to a namespace. That is super common, right? You go, most organizations, that's where people start. Like, I'm a developer, I can have unfettered access to my namespace. I think it's an okay start. I do think you can probably do better, but it's at least some namespaces, for those who aren't familiar, are an interesting concept where you kind of group different areas of your cluster, right? Like, I have a development front-end namespace and then development back-end namespace, or different team namespaces. They don't offer real isolation from a network perspective, right? Namespace A can talk to namespace B. That's not a problem. From an RBAC perspective, they actually can. So I think that's an okay start. What you want to be careful of with stars across the board, you don't want to give people access to create other roles and role bindings, right? Which is kind of tricky, right? Because if you're a developer, all of a sudden now you can create your own RBAC, and maybe that RBAC is elevated or it's given to a service account that you can't. You'll be able to create it in that namespace, a role, which could be appropriate. It just depends. But yeah, stars are, I think they're okay if scoped to a namespace as a starting point. Anything else? Cool. All right. Oh, go.
If you can read out the secrets from, let's say, you're in a namespace, you can read out the secrets in plain text. What would, let's say, you're an attacker and you manage to escape into a namespace or something?
Mm-hmm.
You can list secrets. What would be your next move?
Well, if you have access to secrets, I would try to get out of Kubernetes, right? And go straight to AWS, for example. And oftentimes we see AWS credentials stored in the form of secrets in Kubernetes because people need to access the API or do some IAM stuff. So what I would do is leave Kubernetes at that point and hit an RDS database. You'll probably find secrets to maybe even like a GitHub access token. But a database credential would be pretty juicy, right? Or you can, secrets can vary wildly depending on how you use them. So I would collect the secret, find the target system, and leave Kubernetes and go do more fun things. Good question. Anything else? Cool. All right. We'll see you around the conference. Thank you all for attending, and yeah, feel free to pull me aside later if you want to talk Kubernetes.